Hello, everyone. Welcome to the Bart Show. Hello. Did you hope you guys like that? Hope you guys are doing well. All right. So today's topic is we're going to put multiple buttons on a system. This is the assignment. So we're going to get one multiple color RGB LED. It's a special LED with 4 pins on it. We're going to add 4 non-open or normally open, buttons. Those are those little push buttons. The first button, when we push it, it'll turn the red portion of the LED. The second will turn the green portion of the LED. The third button will turn the blue portion of the LED. And the last button will mix the 3 colors into little pretty blinking flash fashion, LEDs. They'll start to flash back and forth, but it'll mix the colors. Okay. Rules. Okay, no toggle switches. Okay, we're just going to normally open buttons. It'll be easy to cheat like that, but it'll be all right. Okay, when I press the red button, the button will continue to work. So I press it, and it will work. I don't need to hold it down. If there's another one is without holding it down, it will do all the rest of the buttons. So if I go to the next button, let's say the button is blinking red, and I don't turn off that button, but I go to like the green button, it will turn off that red button, and then the green button will blink. And that's example. That's how the system works. Okay, yeah, that's it. So stop the video, design, build code, and run it. These are for people that are they want to challenge themselves without looking at the answer. So stop it, see what you guys got, compare my code. There's multiple solutions. So if you got a certain way, as long as it works. Just don't use any toggle switches. That's all I care about. But if you got a code that seems to work, it's different than mine, so be it. Code is kind of like artwork. So don't think I'm speaking the gospel or anything like that, okay? Because I'm not. All right. New concepts. We're going to talk about the AND binary AND symbol. It's a very handy tool that combines 2 numbers to get the result, and the OR binary symbol. So we're going to go to the whiteboard because I wasn't taught that either. So it's a pretty interesting concept. It's an interesting tool for the logic results. So I'll tell you what I mean by that. Okay, let's go to the whiteboard. All right, so we're going to talk about the AND function. So the AND function, so we talked about, now we know that if, let's say A is greater than B, and then it's and, if A is greater than B, and let's say A is greater than C, do these little brackets right here, then do something. That's and. So if that's true, then that's true. Then we do something in here. Otherwise, it gets ignored. Okay. So these two both have to be true. Let's say we have the symbol or if A is greater than B, or A is greater. So if one of these are true, then let's go ahead and do something. Okay, that's great, but that's not what we're talking about. we are talking about the single and in your code. The single and, then the single or. So what does that mean? Okay. So let's say we have an equation 6 What does that equal? Okay, so your computer, what is actually the equal sign would be over here. So what does that equal? Well, first we turn it into binary. So we know that 0 in a 4-bit 1 1 0, that's 6. Okay, and 1 is 0 0 0 1. That equals 0. Does everybody understand that? So that's why it's a little bit different. So think of these as gates. Remember the AND gates? This is 0 1 0 1 0 0 1 0 0 0 0 equals 0. Okay. So let's say we put something over here as an OR. 6 or 1. That little 6 or 1. So what does that equal? Okay. I know people are just chomping at the bit. You know, they're falling out of their seats. I know. It's pretty exciting stuff. Okay, 1 1 0 0 0 0 1. That is 1 1 1. So that's 7. Completely different. So you could use that, and that's a very fast way of creating logic. Using the binary system is very fast because remember your little embed is, or your little computer, they're not nearly as powerful as your PC. So using the minimal amount of resources to do your calculation will make it a lot more efficient. And so using this is a great way. Thank you, and let's continue on. All right, now we're at the AutoCAD section. I kind of already got it laid out. We're just going to draw on the wires. And this is the library right here. Very useful. This is all handmade. I did this myself. If you guys like my my work and my library, this is something like I could create something that I could put out for free, as long as you have this program. Of course, this program is not free. And I could put on Google Drive there. I need 10 subscribers, so I got 5, maybe 6. So hopefully that will motivate y'all. Anyways, okay, so let's go ahead and go here. RGB goes here. That's an RGB LED. That's just a single LED. It's very cool right there. Let's go ahead and hook these resistors. These R1s, we discussed what these R1s are. They're 330, something 400, something like that. As long as they protect this guy. We don't care about this guy. We care about this guy, because that's the brain. Okay, let's go ahead and move it. Okay, we got one there. Okay, okay. Right in here. Okay. Move it here. All right, let's see if we can zoom it in a little bit. Okay. Okay, let's see if we can do that. All right, let's kind of line it up a little bit better. All right. So we don't want text lines. We want electrical lines. For some reason, I picked red. I don't know why, but you could pick whatever color you want. Okay. Let's move. Wait, I want a line. Okay. Okay. Let's go ahead. I don't know this. Actually, let's go get my buttons out. Okay, that's a nice button right there. Okay. Okay, that's a big one too. I like it. move this guy over here. Move over here. Let's copy. Two, three, four. Okay. Is it just, yeah, it's just 4 buttons, 3 LED. Oh yeah, don't forget the ground. I made the grounds, I made this a long time ago. I have to scale it every time because otherwise it's super tiny. X and Y. There you go. Okay, so buttons, 4 buttons, LED. Okay, all right, we're going to close out the library here. We don't need that anymore. We want to hook the buttons up or the LEDs or LEDs. Let's hook up. Hook up the buttons. Okay. All right. Let's get it kind of aligned a little bit better than that. Yeah. Okay. Click. So you guys should be building. Okay. So, all right. So let's go ahead and put ortho on. PC0. Click. It's pretty easy stuff. It's well, I don't want it to take it too cheap. I mean, it could be a pain in the neck, I guess. Okay, PC0. Okay, PC1. That makes sense. We of course have to put get it kind of honed in a little bit better so I can see it. Sometimes I have to zoom it in. Now, when we put the pull down in the code, there's actually resistors in this thing. You see tiny little dots, like what? There's all these resistors and all these little things. Well, that's when you when you do pull down or pull up. I do pull up. It will engage in a resistor onto the board, and then it will go. It will set its own circuit inside the board, so you don't have to. You don't have to do that. Okay, here we go. Yeah, we'll put. Okay, let's kind of connect it up. Okay, click. Let me see if I can get it to a little bit better than that. Okay. All right. This little comes at a slight angle, but it'll be all right. This is for demonstration only. Okay. When we get into, I'm sure when we, building circuit boards, you got to be pretty precise, but this is for, we just want to be accurate, you know what I mean? And, oh yeah, I remember this. Yep, so what you do right here. Okay, so now let's go. Oh, PC4. Where's PC? Okay, there it is. Okay. Want this to be on PC4? Okay. Oops. No. Oh, bad, Andrew. Bad. Shame on you. Okay. I gotta zoom in so I can be a lot more accurate. There you go. And fire. Let's take that out. We don't need that. All right, let's kind of hook this up. 5, 6, and 8. You see, 7's over here, and it's kind of a pain in the neck for me because you have to count all those pins. When we get into some other ones, you are going to have to use that eventually, but right now, I'm going to take the path of least resistance, which is up here. Five. And actually, it turned out to be fine. 4, 5, 6. That makes sense, right? Now, this is a common cathode. Cathode. You may get some that are common anode. Remember, you have to sync it. Means you have to put the battery in backward. You got to put a battery in and use it. Remember all that? So this is a common cathode. Okay. And these, see that dot right there? That's supposed to means it's grounded. So go right here. And we're going to copy this a couple times. I think I want to copy it. Let's copy about 3 times. Yeah, wait till we do. Our next one's going to be a little more. Well, this is kind of challenging, but the last, we only got a couple left. And the last 2 are BCDs, which are binary coded decimals, the ones that will count. They'll light up. They'll say 0, 1. It's not very easy to understand because we use hexadecimal. But if you understand it, it's really freaking cool. Come on, move it, darn it. There. Okay, we're being a little bit stubborn here. Okay. Okay. Okay, I think it'd just be, it won't look at nearly as bad if we just do this, just kind of connect everything together. That's going to be kind of like, okay. And then it's going to connect to ground. Right here, let me see if I can kind of line it up so I can target it. Actually, I'm going to do ortho. Ortho's really cool. Ortho's my buddy, so. Okay, there you go. So kind of get the target in there. Fire. Pow. Okay, there we go. Now we got to put nodes in. And one, two. Okay. 1, 2, there's 4, 5, 6, 7, 8, 8. Okay. 8, 9, 10, 11. Okay. Oh, there's a ground over here. Okay. That is, we want to ground the. Okay, let me turn ortho off. All right. We want to show Now you can use these. These are the our ground's a ground. You can use the Arduino ground. That's fine too. And you can use the Arduino pins too. But you can't use this pin and this side at the same time. So CN6, I think this is CN5, I think over here. They're connected together. So don't, like, you can't use PA0 and A0 at the same time. I think that's how it goes. I could be wrong. Okay, let me see what we got. But we will find out. I'll give you an update on that, but I'm pretty sure. Come on, ground, darn it. Okay. Okay, click. Let's see if I can connect that a little bit better. Kind of, I'm kind of being a bit of a hurry, but, because, you guys get pretty impatient when it comes to watching my videos. Yeah, I've noticed. Okay. What did I say about 16? Okay. Let me turn ortho off. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'll try 16. A bit big. It'll be all right. So hope you guys have seen the other episodes, but we know that when I put these these nodes, it means they're only connected here. They're to distinguish between crossing over and crossing lines, which are not connected. Because this is do it because this is for you guys, because I'm a cool dude like that, I'm going to put it over here, okay, because that's, in fact, I'm going to put this, it's kind of confusing. Let me put this like really close to the switch, because I agree, that's a little confusing. Let's just put it like over here, okay? Because that just, yeah, that makes sense, right? Okay. Let's just see. Okay. Let's go ahead and put a node. Move this over here. Okay, move it there. Okay. Okay. Just about done. Yeah, there's an inside joke with this. We call it Auto Chad. Yeah, we call this Auto Chad because I said, "Oh, I'm going to learn AutoCAD." He calls it, "You mean Chad?" I'm like, "What, Chad?" He's like, Chad, because if you learn AutoCAD, you're going to get a real high-paying job, and you're going to be getting the chicks. I'm like, "Dad, come on now." I'm a married man, for God's sakes. Come on, gee whiz. So we call it Auto Chad. Okay. That should kind of make sense. I'll put another node, but you should know that those are connected and those lines are crossing are not. Let's put one more node. Just kind of be a little more consistent. Okay. Okay, let's erase all this good stuff. We're just about ready to wrap this up. We're getting a little bit quicker. Let's erase it. All right. Let's go ahead and go the extra mile. You know, I really want to go the extra mile. Let's fill these. These are always helpful. Kind of. Sometimes they won't fill in all the way, and that's okay. We're just trying to make sure that you see where everything is at. Oh man, I'm getting better at this. All right, let me go. That's it. Do you guys need anything else? Do you want to switch 1, switch 2, switch 3, switch 4? You guys should know that. Okay. So I'll just give you guys the time. Take a snapshot. That's the circuit. And let's go off to the pre-code talk. All right, we're here to this is the pre-code part, so let's go ahead and get down to it. This is a very important part. I know everybody goes to the code part, but if you don't go to the pre-code part, you're missing out. So first, what we're going to do is initialize the RGB as one LED. Then initialize the RGB into 3 variables and initialize the 4 buttons. We're going to define time. We're going to random time and off. So we're going to go to the main. Inside the main, we have RGB equals 0, int num equals 0, and we have a crazy num equals 0. That's the super while loop. So we're going to ask the question, is the button pushed? If it's yes, is the number 1? If it's no, then we're going to 0 because we initialize it to 0. Or 1 equals 1, number equals 1, we're going to turn on the LED. Okay. Then, if you follow the line, while the number is 1, is the button pushed again? That's yes. It's going to go 1 and 2 equals 0, the number equals 1. All right. There's also a blue button. Is it pushed? Is the number 2? Same thing. 1, 2, 0. Then we're going to store the numbers 2, and while the number's 2, the blue light will turn on until it's pushed again. Yep. And then we got, well, it's supposed to be 3. Is the number pushed? Yes. Is the number 3? Yes. 3 and 4 goes on. That's supposed to be while the number's 3, but you guys will get used to it. Okay, and then we have a 4th button. Is the crazy button pushed? Yes. Is the number 4? So you can add and then let's go all the way back. So that right there will go all the way back and store it. So I hope that helps. All right. So now we're going to open up a new file. So let's go ahead and erase that. Erase the program's name that come up. Okay. Multiple buttons. Okay, let's go find it. Okay, multiple buttons .main.cpp. All right, let's go ahead and put some comments here. Okay. And author Andrew Dunlop, aka Engineering Bard. All right. Engineering. Earring. Okay. All right. Today we're going to learn how to use the buttons. Multiple buttons. Okay. With multicolor LED. Plus a colorful LED at the end. Okay, today's date, 5/27/2025. All right. Let me look through here. Okay, let's go ahead and declare the variables. Bus out. That's camel case, that's right. RGB. PC. 4. PC 5. And PC 6. I'm going to slow it to type bug, so you have to bear with me. I know there's like some coding programs, they're like, it's like super fast. I'm like, okay. Digital out. Okay. Hold on, I got to concentrate. All right. We're going to copy paste all that. Red LED, PC 0, PC 0. Just going to copy and paste it. Okay. Now we're going to change the names. So we're going to change it to blue. And then green LED. Yep. That'll do it. Wait a minute. These things are out. These things don't need buttons. They don't need the pull up. What the heck am I doing? All right, there we go. That makes it okay. At least we don't need pull ups. Digital in. Red button. And that is PC 0. Pull up. That engages the resistor in the board. Dang, I think it's touchy, you know what I mean? You have to. Okay. I'm going to copy and paste this because I know we're all in a hurry. Okay. Okay, paste it again. Let's go ahead and change the button names. Oh, we got one more. That's right. That's right. There's red button, blue button, and green button. And also we're going to do a crazy button. I think that's a cool name. I don't know. You can call it whatever you want. Wait a minute. PC 1, 2, 3. Oh, wait. I got to change these. My bad. There you go. That makes sense, right? You can't have your buttons and be the same port. No? All right, let's go define time as, of course, 1 second, which I don't think we ever use this, but I don't know. I think it's just force a habit. Several, paste. Okay, all right. We're going to find random time as, we're going to do 500,000. I think it's 500,000. Yeah. And then we're going to define on, as we know that's 0. Define off as 1. On 1, off 0. Okay, now let's go inside the main. We're going to declare our holding variables. RGB equals 0. Light, you got to do it outside of the main, no, inside the main, but outside of the super while loop. Int num equals 0. Okay. It's 0. Okay, now here's what we're all waiting for. Is the algorithm. So if red button equals 0, then we must check if num, and there's the and 1. That's and 1. Got to put these brackets there, so it does that first. Equals 1. In actuality, it's kind of a weird logic. We actually turn the button on by the else loop and not the if loop, because we kind of want the if to basically turn it off, because then it has a value. Okay, so it's a little bit counterintuitive, this algorithm, but it really works very well. Num num or num num. I got it. There you go. That's the symbol for or. Okay, that line. 1. So 0 and 1, remember, or will pass the 1, even if it's a 0. Okay. So, oh yeah, capitalize the off. It was giving me an error. Then we want to turn on the red LED. That basically the LEDs are like your system. Turn it on, turn off. The LED, all these guys do, it controls a system. Now I know LED is nothing special, but if you think of what it's doing, it is doing something special. It's just that we're just putting it at a very smaller scale. Now this right here is very important. The while loop with a semicolon. That one, I thought that was cool. I thought that was cool. That holds the value of the button. So that's sort of like the listener, the listener algorithm is when you add the while button. There's the listener and the event when it comes to these buttons. Hope you guys find this kind of interesting. I know some of my viewers are not engineers, but I hope they, this is pretty interesting stuff, and we're, this is very powerful stuff. So let's go copy and paste this. Okay, I gotta check out the next page. Okay, here we go. All right, copy, because we are in a hurry. Paste. Okay. We want to change the names to blue button. We want to change that to 2. So that says if 2 and 2, which has to equal 2. Then 2 and 1 is 0. That's going to turn the LED. That's going to turn the blue LED off. Else, if there wasn't any number in there, it will be a 0. It's going to go 0 or 2. It's going to equal 2. So now you got the 2 stored up in the number way up above in the main. Let's copy paste it again. Crazy button. I don't know. I could have said colorful button, but I don't know. I like to spell out the names completely. I know some do, like some, they'll do if X equals Y, if button Z equals. I find that kind of lazy. It's really confusing. If button X equals Y and Y equals Z and Z equals all that other bullshit. It's kind of like, man, I feel like just walking out of the classroom. It's very inconsiderate because you don't know what Y and Z is. So this is the way. I think this is the proper way to code. We got to change some variables real quick. Nope, that's right. We got to do the crazy button. and 4. You can put as many buttons as you want. You could put 20 buttons this way, 100 buttons this way. It goes on. As long as you have enough ports. If you do this algorithm, it's pretty flawless. I think it's cool. I really do. Okay, RGB equals 0. Okay, this is a little bit different. A little bit different. We want, okay, crazy numb, that's right. Yep, crazy numb. I think I have to lowercase it. Oh, that's right, semicolon. What is that darn semicolon? We want to erase that. So it goes to 4. Now, crazy num, we got to completely change the numbering system because we don't want to mess around with the number. That keeps track of the buttons. So we had to initiate a whole different variable so the numbers will change. That's random at mod 5. Remember, that's 2 to the n minus 1. We only had 3. 2, that equals 6. Minus 1, that's 5. Okay, we're counting everything. PC4, that's the bus out. I just wanted you to check that out. So it's completely isolated. Okay. All right. Let me check something. We got to change some of these variable names. Oh, yeah, that's right, the weight. All right, there we go. Rate ran time. Okay, semicolon. See, the code is, it's getting a little bit more sophisticated than Hello Blinky, so. Okay, put the crazy button. Oh yeah, there's a big space right here. I hate it when that happens. Yeah, they don't have a format all, so you have to bear with me on how it looks. There you go. There's the red button equals 0. Okay, let's check it out. Looks pretty good. We got some nesting if loops. Okay, red button, blue button, green button, and of course there's the crazy button. Okay. Okay, well let's go. We're about to go to the proof of concept, and I will see you guys there. Just checking it over. There you go. So let's go ahead and look at this little system right here. So see how the oscilloscope, see how it's on high, and then and then it goes down to low. That's when the button engages. So that's the red button. Hit it once, hit again, turns off. Quite responsive. The green button, hit it once, turn off. And the last button, I'm trying to get my finger out of the way. Blue button, turns off. Hit it again, different color, turns off. Thank you. Hope you guys subscribe. And we'll see you next on the Engineering Bart Show.